Right now, as you read these words, you are participating in a multi-layered journey of apocalyptic proportions. You are currently moving at a speed that is almost impossible to imagine, yet your coffee does not spill. Your heartbeat remains calm. You do not feel the agonizing, crushing rush of velocity. Look at your hand resting on the table. It seems calm. The floor beneath your feet feels like an absolute, immovable foundation. You trust this stillness. You rely on it to maintain your physical balance and your psychological sanity. But the truth is that this stillness is a biological hallucination. It is a neurological lie constructed by your own brain to keep you from becoming utterly paralyzed by the sheer chaotic velocity of the universe. The physical universe is a place of incomprehensible kinetic energy. Nothing in the cosmos is at rest. The strange part is not only that you are moving fast. The strange part is that the motion is so complete, so shared, and so deeply built into everything around you that your body calls it stillness. This stillness is your first illusion. Your senses are not broken. They are simply doing exactly what they were built to do. They report pressure, balance, and vibration. Your body is not a speed detector. It is a change detector. This simple fact is why the quiet room can hide something enormous. At this exact moment, if you are not near the poles, the ground beneath you is being carried around Earth's axis. Earth turns once in roughly 24 hours. That rotation means the surface is moving sideways all the time. Near the equator, the surface moves at approximately 1,670 kilometers per hour. In the time it takes you to simply blink your eyes, you have already moved hundreds of meters. This is faster than a commercial jet. It is faster than the winds of any ordinary storm. Most significantly, it is faster than the speed of sound. This means that the chair you are sitting in, the one that feels so ordinary, is currently moving faster than the sound of your own voice can travel through the air above it. You are a passenger on a planetary centrifuge, being thrown eastward at a velocity that defies human intuition. This is confirmed science. The data shows that we are sitting on a surface moving faster than sound, and yet we feel absolutely nothing. And the reason you do not feel it is not because the motion is small, it is because your body can only sense acceleration changes in velocity, not velocity itself. This is a fundamental fact of physics called the equivalence principle. Imagine you are inside a smooth train with the windows covered. For a while, your body may not know whether the train is stopped or moving. A phone lying on the seat beside you does not fly backward just because the train is traveling quickly. The cup in your hand does not care about speed by itself. It only cares about braking, turning, or jolting. This is precisely what is happening to you right now. Your body is not outside the system watching it spin. Your body is inside the spin. You are like a passenger on a boat carried by a broad river, able to walk normally on the deck because the deck is carried too. Your bones are not pressed backward because the floor, the air, the oceans, and everything you touch are spinning with you. This does not make the motion unreal. It makes the stillness local. Local stillness is not a lie, but it is much smaller than we imagine. Within the agreement of nearby things, the table is still relative to the floor, and the cup is still relative to the table. But the moment you change your frame of reference, that truth dissolves. The mechanism responsible for this deception is a tiny, fragile structure buried deep within your skull. Inside your inner ear, there are microscopic sensors filled with fluid. These sensors act like a biological alarm system. When you change direction or speed, the fluid sloshes around, sending signals to your brain. It is a tool designed for the prehistoric plains, warning you when you lose your footing or a predator lunges. But when you are moving smoothly at 1,670 kilometers per hour, the fluid settles. The sensors have nothing to report. In the absence of a warning signal, your brain simply assumes that you have stopped. It is a terrifying architectural flaw in the human machine. The universe can hurl you through the dark at millions of miles per hour, but as long as the ride is perfectly smooth, your body will never sound the alarm. To survive, the brain acts as a ruthless editor. It filters the world. It prioritizes information that changes and might require an immediate response. Anything constant and predictable is tuned out. Your brain erases the terrifying velocity of the cosmos in the exact same way it tunes out the hum of a refrigerator. Think of the air you are currently breathing. Even the atmosphere is a captive part of this violent motion. It is not left behind as the planet spins. It is dragged along, held in place by the crushing tether of gravity. This is the only reason you do not experience a constant apocalyptic wind rushing past you at supersonic speeds. You and the atmosphere are traveling together. But consider the fragility of this arrangement. We survive because this invisible gas perfectly matches the speed of the solid rock beneath it. If the atmosphere were to suddenly slip, if the grip of gravity faltered, and the air stopped rotating with the crust, the result would be instantaneous global annihilation. Supersonic winds would scour the surface of the planet, stripping away forests and shattering cities. We are living inside a high-speed wind tunnel, where the air is moving so fast it feels entirely still. We blindly trust that the system will never fall out of synchronization. This realization transforms the most basic rhythms of your life. We watch the sun rise and find a romantic beauty in the cycle of dawn. But you are not watching a celestial performance. You are a captive audience strapped to a rotating sphere. Morning arrives because the planet has relentlessly rotated your location out of the shadows and thrust it into the irradiated gaze of a star. Evening comes because that same spin is dragging your body back into the dark. The Earth is a rotisserie, turning us toward the fire and then turning us away, with no regard for the fragile organisms clinging to its surface. For most of human history, the idea that the Earth was rotating was considered obviously wrong. If the Earth is spinning that fast, people asked, why don't objects fly off the surface? Why doesn't a bird that takes flight come down in a different spot? These were not stupid questions, they were reasonable extrapolations from everyday experience. But proof eventually arrived in 1851 in a cathedral in Paris. A physicist named Léon Foucault hung a 67-meter pendulum from the dome of the Pantheon. A pendulum maintains its plane of motion relative to space. It does not care about the Earth beneath it. If the Earth were truly still, the pendulum would swing back and forth over the same line forever. But as the hours passed, the pendulum's path appeared to rotate. It was tracing a circle across the floor. The pendulum wasn't turning, the floor was. The Earth was rotating beneath it. For the first time, people could watch the rotation of the planet in real time. Today, we use ring laser gyroscopes that are so sensitive they can detect the tiny variations in Earth's rotation caused by weather patterns and the movement of tectonic plates. We can measure these changes to a precision of microseconds per day. The data confirms that Earth's rotation is not fixed. It is actually slowing down. The Moon's gravitational pull creates tidal bulges that drain energy from Earth's spin. We are decelerating by approximately 1.78 milliseconds per century. This sounds tiny, but it implies a different past. When Earth was young, a day lasted only about 6 hours. Life has evolved entirely within a gradually slowing rotation. This motion, this supersonic spin that exceeds the speed of sound, is the smallest layer in the stack. It is the slowest thing your body is currently doing. If you enjoy deep investigations into the hidden mechanics of reality like this, subscribe now. The investigation is only beginning, because while the Earth spins beneath you at 1,670 kilometers per hour, it is also performing a second great motion. It is falling around its star at a speed that makes the sound barrier look like a slow walk. The investigation starts with the floor beneath your feet, but it is about to move into the freezing void of the solar system. In the time it takes you to simply blink your eyes, you have already moved dozens of kilometers through the freezing void of space. We have established that the ground beneath your feet is spinning faster than the speed of sound, a motion so smooth that your body classifies it as absolute stillness. But as we step away from the local rotation of the planet and look toward the solar system, the numbers stop being impressive and start being genuinely terrifying. This is our first true scale escalation. The Earth is not merely spinning, it is traveling along a vast, nearly circular path around the Sun at an average velocity of approximately 29.78 kilometers per second. 29.78 kilometers per second. To make that number a physical reality in your mind, consider a standard military rifle. When a bullet leaves the barrel, it travels at about 1 kilometer per second. It is a speed so fast the human eye cannot track it. It is the definition of lethal velocity. Yet, the chair you are sitting in, the one that feels so anchored and safe, is currently moving through space at 30 times the speed of a rifle bullet. You are a passenger on a high-speed projectile that has been screaming through the cosmic vacuum for 4.5 billion years without ever slowing down, without ever stopping to refuel, and without generating a single flicker of sensation in your nervous system. This is not speculation. This is confirmed science, measured to a precision that defines our modern understanding of the universe. Think about your morning routine. Think about the time it takes you to make a single cup of coffee, from the moment you turn on the machine to the moment you take the first sip. On average, that takes about 7 minutes. In those 7 ordinary minutes, the Earth has traveled approximately 12,742 kilometers. 12,742 kilometers is the entire diameter of the Earth. While you were waiting for your coffee to brew, you traveled a distance equal to the entire width of the planet you call home. While you slept for 8 hours last night, the Earth carried you 860,000 kilometers, more than twice the distance from the Earth to the Moon. You cover this distance every single night, and yet the water in your glass remains perfectly level. The reason for this sensory silence is the same principle we discussed regarding rotation, but escalated to a planetary scale. You and everything you can perceive, the atmosphere, the oceans, the buildings, are trapped within the same closed system, moving at the identical blistering speed. There is no roaring wind rushing past you because the air is moving with you. There is no physical sense of being carried forward because there is no change in your momentum. But we must address the mechanism of this motion because the way we typically visualize our orbit is fundamentally wrong. We imagine the Earth as a motorized vehicle flying through space, following a predetermined track. The physical reality is much more precarious. The Earth is not flying, it is falling. An orbit is not a state of powered flight. It is a continuous, uninterrupted state of perpetual freefall. To understand this, imagine you are standing on a high cliff and you throw a stone. Gravity pulls it down, but if you could throw that stone fast enough, 30 kilometers per second, it would travel so far forward that as it fell, the Earth's surface would curve away beneath it. The stone would keep falling, but it would keep missing the ground. That is exactly what you are doing right now. The Earth is perpetually falling toward the Sun's massive gravitational well, but it is moving sideways so fast that it misses the Sun every single second. You are currently suspended in a permanent high-wire balancing act between two catastrophic absolutes. If our sideways velocity were to slow down even slightly, the Sun's gravity would overpower our momentum and we would spiral inward toward a sea of nuclear fire. If we moved a fraction too fast, we would fly out into the freezing dark as a dead rogue planet. We are living on the razor's edge of a cosmic inferno, kept alive only by the desperate, frantic speed of our own sideways momentum. For most of human history, this reality was not only unknown, it was considered an impossibility. The geocentric model, the idea that the Earth was the fixed center of everything, dominated for nearly 2,000 years because it matched our senses. The physical arguments against Earth's motion seemed bulletproof. If we are moving that fast, why don't we feel it? Why do objects thrown into the air come back down in the same place? It took 2,000 years from Aristarchus of Samos to Isaac Newton for humanity to accept that our feeling of stillness was a lie. The data finally settled the debate in 1727 through a phenomenon called stellar aberration, discovered by James Bradley. Bradley noticed that stars do not appear exactly where they should be. They appear slightly shifted in the direction of Earth's motion. He used an analogy that remains the best way to understand this. Imagine you are standing in vertical rain. If you stand still, you hold your umbrella directly above your head. But if you start running, the rain seems to hit you from an angle in front of you, and you have to tilt the umbrella forward to stay dry. The Earth is running through the rain of starlight at 30 kilometers per second, and we have to tilt our telescopes to catch the light. This was the final, undeniable proof that the Earth was in motion. Today we can measure this velocity with extraordinary precision. We know that the Earth's orbit is not a perfect circle, but an ellipse. This means your speed is not even constant. In January, when we are closest to the Sun, the Earth moves slightly faster, about 30.3 kilometers per second. In July, we slow down to about 29.3 kilometers per second. Even as you sit there, the planet is subtly accelerating or decelerating as it navigates the Sun's gravity, and yet your body registers absolutely nothing. The stillness you experience in your quiet room is not a true foundational peace. It is the numb sensory deprivation of a biological creature that has been falling for so long it has simply forgotten what solid ground actually feels like. You are a passenger on an invisible runaway train with no windows, sitting in the dark and comforting yourself with the lie that you haven't even left the station. We have stacked the first two layers, a supersonic rotation and an orbital velocity 30 times faster than a bullet. But we are still using the Sun as our anchor. We are assuming the Sun is a fixed point in the dark. The truth is much more unsettling. The Sun is not standing still. It is a moving star carrying its planets, its moons, and every human story along with it, on a journey that makes the speed of a rifle bullet look like a slow walk. The investigation is about to leave the orbit of our star and enter the rotation of the galaxy itself. Everything we have discussed so far, the supersonic spin of the Earth beneath your feet and the bullet speed plunge of our orbit, has relied on a single, comforting assumption. We have been using the Sun as our anchor. We have treated the center of our solar system as a fixed, immovable lighthouse in the dark, a silent witness around which our world performs its frantic dance. But here is where the model breaks. The Sun is not a fixed point. It is not sitting at the center of the solar system waiting patiently for the planets to come around again. The Sun is a traveler, and it is dragging you, your home, and everything you have ever known into a journey that makes our previous layers of motion look like a slow, stationary crawl. This is not a metaphor or a poetic exaggeration. This is established physics measured by the collective data of modern astronomy. Right now, the Sun is orbiting the center of the Milky Way galaxy. Specifically, it is falling around a region approximately 26,000 light-years away called Sagittarius A star, the supermassive black hole that acts as the gravitational heart of our galaxy. To maintain this orbit, to keep from being flung out into the intergalactic void, the Sun must travel at an average velocity of approximately 230 kilometers per second. 230 kilometers per second. In the time it takes you to simply take a single, deep breath, the Sun has carried you nearly 1,000 kilometers through the galaxy. By the time you finish reading this sentence, you have moved further through the Milky Way than the distance from London to Paris and back. To understand the sheer magnitude of this velocity, we have to look at the peak of human engineering. In 2018, NASA launched the Parker Solar Probe, a machine specifically designed to be the fastest human-made object ever built. It is a marvel of heat shields and high-performance thrusters, shaped and optimized to dive into the Sun's corona at speeds that defy belief. In 2024, it achieved speeds of approximately 192 kilometers per second. It is the fastest thing we have ever managed to scream into the dark. Yet, the Parker Solar Probe, at its absolute limit, cannot even keep pace with the casual motion of the star it is trying to study. The Sun is moving through the galaxy faster than our most advanced racing machine can possibly travel. We built a projectile to chase a star, only to find that the star was already winning a race it wasn't even trying to run. The Sun is not moving alone. It is a cosmic shepherd dragging a massive family along with it. Every planet, every moon, every asteroid in the Kuiper Belt, and even the Voyager probes currently exiting our system are all gravitationally bound to this single vector of travel. You are currently sitting in a chair that is performing 3 simultaneous speeds. You are spinning at 1,670 kilometers per hour, orbiting at 30 kilometers per second, and being dragged across the galaxy at 230 kilometers per second. We are stacked in a hierarchy of speed, and this third layer alone is nearly 8 times faster than the orbital velocity that Adi felt incomprehensible. For most of human history, the idea that the Sun was in motion was not just unknown, it was conceptually impossible. We spent 2,000 years from Aristarchus to Copernicus fighting an intellectual war just to prove that the Sun was the center of our world. Once we finally accepted heliocentrism, the Sun became our new floor. It became the fixed point that gave us stability. To suggest the Sun itself was moving felt like removing the final foundation of reality. It wasn't until the 18th century that the first cracks in the Sun's stillness appeared. In 1718, Edmund Halley, famous for his comet, noticed that the positions of stars in the sky were subtly different from the records left by the ancient Greeks. The fixed stars weren't fixed, they were moving. And if the stars were moving, the Sun, being a star, likely was too. In 1783, William Herschel confirmed this by observing what he called the solar apex. He noticed that the stars in front of us seemed to be spreading apart, while the stars behind us seemed to be closing in. It was the visual equivalent of driving down a highway. Objects in the distance broaden as you approach them. Herschel realized the Sun was driving toward the constellation Hercules. The data shows that we are not just drifting, we are participating in a cycle so vast it transcends the history of our species. This cycle is known as the galactic year. It is the amount of time it takes the Sun to complete one full lap around the Milky Way. On average, this takes between 225 and 250 million years. Let that number sit for a moment. Since the Sun was born 4.5 billion years ago, it has completed approximately 20 orbits of the galaxy. When the Sun began its current lap, the one we are on right now, the most complex life on Earth was the early dinosaurs. There were no birds, there were no flowers, there were no humans. When the Sun began its previous lap, the 19th orbit, there were no dinosaurs at all. We were in the Permian period, just before the greatest mass extinction event in the history of the planet. Human civilizational history, every empire, every book, every invention, occupies a sliver of time so small relative to this orbit that it cannot even be accurately drawn on a timeline. We are microscopic passengers on a star that has been circling this galactic drain since before the Earth even had a solid crust. However, the Sun's journey is even more complex than a simple circle. It does not move through the Milky Way in a flat, predictable line. According to modern astronomical models, the Sun bobs like a dolphin moving through water. As it orbits the galactic center, it oscillates up and down, crossing the equator or midplane of the galaxy every 30 to 40 million years. Right now, we are believed to be slightly north of the galactic plane, moving further in that direction before gravity eventually curves us back down. Some scientists have speculated, though it remains an area of active debate, that this vertical bobbing might be tied to historical mass extinctions. The theory suggests that as we pass through the denser regions of the galactic plane, we encounter more interstellar dust and debris, which could disrupt the comets in our outer solar system and send them screaming toward Earth. While this correlation is not yet proven, the fact remains: your star is not just a light in the sky, it is a 3D navigator weaving a graceful, rhythmic wave through a disk of 100 billion other stars. The stillness of your room is now more than just a biological hallucination, it is a mathematical miracle. You are being carried by a star that outpaces our fastest rockets, performing a 230 million-year lap while bobbing through the galactic plane in a slow-motion wave. And yet, despite this 230 kilometers per second velocity, your senses report nothing. There is no turbulence, there is no roar of the cosmic engine. We are passengers inside a passenger, shielded by the Sun's own magnetic influence, moving through a medium we can barely perceive. But space is not empty. As the Sun drags us through the galaxy at these impossible speeds, we are actually plowing through a physical medium, an interstellar wind that we are only now beginning to understand. This is not speculation. We have actually felt the wind. The investigation is about to leave the safety of our solar system's bubble to look at the local fluff, the interstellar cloud we are currently colliding with at 26 kilometers per second. Everything we have established so far, the supersonic rotation of your chair, the bullet speed orbit of the Earth, and the Sun's 230 kilometer per second race around the galactic center, rests on the assumption that we are moving through a perfect empty void. We visualize the solar system as a collection of clean, geometric spheres sliding through a frictionless vacuum. But here is the first major complication. Space is not empty. This is a fact that most of us intellectually accept, but rarely fully digest. The space between the stars is filled with gas, dust, charged particles, magnetic fields, and radiation, a thin but very real physical medium. As you sit there right now, the entire solar system is not just drifting, it is plowing through this medium like a ship through a heavy sea. We are currently experiencing an interstellar wind that is striking the boundaries of our world at velocities that make our fastest jet engines seem stationary. The data shows that we are not just passengers on a galactic escalator, we are active navigators moving through a physical landscape. To understand the nature of this collision, we have to look at what astronomers call the local standard of rest. Think of the Milky Way as an escalator. Most stars in our immediate neighborhood are moving in the same general direction at roughly the same speed. But just like people on an escalator, stars have their own individual walking speeds. Some drift left, some right, some move slightly faster or slower than the crowd. When you measure the Sun's velocity relative to these neighboring stars, you find it has a peculiar velocity of approximately 13.4 kilometers per second. This is our star's individual motion through the neighborhood, but the more significant measurement, the one that introduces the most profound complication to our sense of safety, is our motion relative to the gas and dust itself, us. Right now, the solar system is colliding with a specific structure known as the local interstellar cloud, often nicknamed the local fluff. The Sun is plowing into this cloud at a speed of approximately 26 kilometers per second. 26 kilometers per second. In the time it takes you to simply adjust your posture in your chair, the leading edge of our solar system has slammed into 26 kilometers of interstellar material. This is not speculation. It is a measured reality confirmed by multiple independent missions. To visualize this, imagine you are driving a car at high speed down a highway. As long as the windows are rolled up, you feel nothing but the smooth vibration of the road. The air inside the car is still. You can hold a cup of coffee. You can speak in a whisper. But the moment you hold your hand out the window, you feel the violent, invisible pressure of the wind. You realize that you aren't just moving, you are interacting with a medium that is pushing back against you. The solar system is that car, and its window is the heliosphere, a vast magnetic bubble generated by the Sun's solar wind that surrounds and shelters every planet, every moon, and every human being. We are currently passengers inside a magnetic bubble that is being compressed and shaped by our 26 kilometers per second collision with the local fluff. As we plow forward, the front of this bubble, the bow, shock, is flattened and compressed by the pressure of the interstellar medium, while the back of the bubble is stretched out into a long comet-like tail that follows us through the dark. The only reason you do not feel the wind of the galaxy is because you are shielded by this bubble. The heliosphere acts as a cosmic hull, diverting the flow of interstellar gas and radiation around us. Without this protective membrane, the high-energy particles of the interstellar medium would scour the Earth's atmosphere, fundamentally changing the chemistry of our world and likely making life as we know it impossible. For decades, the existence of this wind was a theoretical conclusion drawn from the way light from distant stars was absorbed by the gas between us. We knew the wind was there, but we had never touched it. We had never felt the spray of the galactic ocean against our hull. That changed in 2012. Voyager 1, a machine launched in 1977, and now the most distant human-made object in existence, finally crossed the heliopause, the absolute outer boundary where the Sun's influence ends and true interstellar space begins. The data recorded by Voyager 1 was startling. It didn't find a gradual fade into nothingness. It found a definable physical wall. As the probe crossed the boundary, it recorded a sudden, sharp increase in the density of the plasma surrounding it. It felt the magnetic fields of the galaxy shift and take hold. For the first time, a human instrument felt the interstellar wind for us. It confirmed that our solar system is a ship with a hull, and that hull is currently under constant high-speed pressure from the medium we are moving through. But there is a deeper complication hidden in the measurements provided by another NASA mission called IBEX, the Interstellar Boundary Explorer. IBEX does not travel to the edge. Instead, it sits near Earth and detects neutral atoms, stray particles from the interstellar wind that manage to leak through our magnetic defenses and drift into the inner solar system. By measuring the speed, direction, and composition of these atoms, we can map the weather of the galaxy. What IBEX has revealed is that we are currently in the middle of a transition. We have been traveling through the local interstellar cloud for somewhere between 45,000 and 150,000 years, but we are now approaching its edge. In the next 10,000 to 20,000 years, a mere blink in cosmic time, the solar system will exit the local fluff and enter a different region of space called the G-cloud. This is a profound realization. We are not just moving through a static, unchanging void. We are travelers moving through changing environments. When we exit our current cloud and enter the G-cloud, the pressure on our heliosphere will change. The wind might blow harder or softer. The amount of cosmic radiation reaching Earth might shift. We are currently passengers inside a bubble that is changing its environment in real time. The quiet, still room where you are sitting is currently sailing through a specific galactic weather system that our ancestors did not inhabit and our descendants will eventually leave behind. Everything we have discussed so far, the rotation, the orbit, the galactic race, and the interstellar wind, shows that your body is participating in a stack of non-cancelling, cumulative motions. 1,670 kilometers per hour of rotation, 30 kilometers per second of orbit, 230 kilometers per second of galactic drift, 26 kilometers per second of interstellar collision. These aren't alternative speeds, they are all happening simultaneously. Your chair is carrying the weight of all of them at once, and yet the cup of coffee on your table remains as calm as a mirror. We have spent this investigation looking at how we move through the space of our galaxy, but we are still assuming that our galaxy is a peaceful, isolated island. We are assuming the Milky Way is just sitting there. The truth is much more violent. The Milky Way is not a finished, stable object. It is currently in a state of high-speed gravitational collapse toward a massive neighbor. We aren't just moving through space, we are falling toward a collision that has already begun. The investigation is about to leave the safety of our interstellar neighborhood to look at the 110 kilometer per second plunge toward Andromeda. On a clear night in the northern hemisphere, if you know where to look, you can find a faint, elongated smudge of light in the constellation Andromeda. It does not look like much. It is barely brighter than the background sky, often ignored by anyone not specifically searching for it. Yet that smudge is a collection of roughly 1 trillion stars, making it substantially larger than our own Milky Way. But that is not the terrifying part. The terrifying part is what that light is telling us about our own motion. Until now, we have discussed your journey as a series of nested rotations and orbits, movements through the space of our galaxy. But as we look at that smudge, the narrative changes. We are no longer just drifting or orbiting, we are falling. The Milky Way and the Andromeda Galaxy are currently on a direct, high-speed collision course. We are falling toward that smudge of light at a velocity of approximately 110 kilometers per second. 110 kilometers per second. In the time it takes you to simply blink your eyes, you have fallen 110 kilometers closer to a trillion-star impact. By the time you finish this sentence, you have covered the distance between New York and Philadelphia. This is not a drift, it is a plunge. This is not speculation, it is measured science, confirmed through a phenomenon called blue shift. In 1912, at the Lowell Observatory in Arizona, an astronomer named Vesto Slipher measured the light spectrum of that smudge. He discovered that the light was compressed. Just as a siren sounds higher in pitch as it rushes toward you, light waves are shortened and pushed toward the blue end of the spectrum when the source is approaching. Andromeda's light is blue. It is a cosmic warning signal telling us that the gap between us is closing with every passing second. To understand the scale of this fall, you must look at that smudge not as an object, but as a message. The photons hitting your eyes right now, the ones that allow you to see that faint glow, left their source approximately 2.5 million years ago. Think about the world that light left behind. When those photons began their journey toward your eyes, Homo sapiens did not yet exist. Your ancestors were early Homo habilis, small-brained creatures in East Africa, just beginning to experiment with the very first crude stone tools. Fire had not been tamed. Language was a future invention. The modern human brain, the one you are currently using to process this information, was still millions of years away from evolving. That light has been traveling through the freezing dark for the entire duration of your species' existence, and during every single second of those 2.5 million years, the Milky Way has been falling toward Andromeda, and Andromeda has been falling toward us. While your ancestors were learning to walk upright, while empires rose and fell, while you were born and grew into the person you are today, this 110 kilometer per second closing of the distance has never paused for a single breath. But here is the twist. We speak of this collision as a future event, something scheduled to happen in approximately 4.5 billion years. But the data shows that in the gravitational equations, the collision has already begun. A galactic collision is not like two cars hitting each other on a highway. It is a slow, patient, gravitational embrace. Long before the stars themselves arrive, the invisible dark matter halos that surround both galaxies have already begun to overlap and interact. The scheduled merger is simply the final, visible culmination of a process that is currently, actively underway. You are not waiting for a collision. You are living inside the early stages of a merger event that neither galaxy can escape. This realization creates a profound complication in our understanding of stillness. You are participating in a galactic merger right now. The gravitational relationship has already been written into the math. The two galaxies are already bound into the same slow story. We must address the word collision itself because it is deeply misleading. It suggests a violent smashing of objects, but the physical reality of a merger is far more haunting. Stars are extraordinarily far apart relative to their own size. To visualize this, imagine the Sun is scaled down to the size of a single marble, about 1 centimeter wide. In this scale, the nearest neighboring star would not be across the street. It would be 300 kilometers away. When the Milky Way and Andromeda eventually merge, they will pass through each other like two ghosts. The vast majority of the trillion stars in Andromeda will never touch a single star in the Milky Way. There is so much empty space between the suns that they will simply slide past each other, caught in a new gravitational dance. The collision is actually a redistribution of orbits. The galaxies will stretch and distort each other, flinging stars into new, wild trajectories. Gas clouds will slam together, triggering the birth of millions of new stars, lighting up the sky with a brilliant blue-white glow. Over hundreds of millions of years, the two spirals will lose their shape, eventually settling into a single, massive, rounded cloud of stars. Astronomers have already named this future home Milky. It will be a world without the familiar spiral arms of the Milky Way, a giant elliptical galaxy where the suns of two different worlds have finally agreed on a single, shared motion. But for you sitting in your chair, the terror is in the invisibility of the fall. We have stacked the speeds, 1,670 kilometers per hour of rotation, 30 kilometers per second of orbit, 230 kilometers per second of galactic drift, and now this 110 kilometers per second plunge toward Andromeda. Your body registers absolutely none of it. You are falling toward a trillion-star merger at 110 kilometers per second, and your coffee remains as calm as a mirror. The stillness of your room is not just a biological hallucination, it is a cosmic shielding. You are a passenger on a galactic ship that is currently entering the first stages of a merger, yet you feel only the weight of your own body in the chair. This 110 kilometers per second fall is just one component of a much larger, much more organized motion. We have been looking at the relationship between two galaxies, but as we step back even further, we find that our entire neighborhood, the Milky Way, Andromeda, and dozens of smaller companions, is being carried by a current so massive it wasn't even discovered until the 1980s. The investigation is about to leave the local fall and enter the cosmic watershed. Everything we have discussed, every rotation, every orbit, every merger, is being dragged toward a single, invisible drain in the dark. The investigation moves now to Laniakea and the Great Attractor, where the speed doubles again, and the why of our motion becomes a question of life and death for the entire universe. We have reached the point in our journey where local landmarks, the spin of your planet, the orbit of your star, and even the collision of your galaxy, begin to feel like small domestic concerns. Everything we have discussed so far is currently being swallowed by a motion so vast that it was functionally invisible to human science until the 1980s. At this exact moment, you, your chair, and the entire Milky Way galaxy are being dragged toward a specific, ominous region of space at a velocity of 630 kilometers per second, 630 kilometers per second. To humanize that number, in the time it took you to simply read that sentence, everything you have ever known moved nearly 3,000 kilometers through the dark. In the time it takes you to take a single, shallow breath, you have traveled a distance equal to the entire width of France. This is not speculation. This is confirmed science measured directly by tracking the peculiar velocities, the individual walking speeds, of thousands of surrounding galaxies. But to understand the true terror of this motion, we must look at the why. We are no longer talking about circles or orbits. We are talking about the cosmic watershed. For decades, astronomers were quietly irritated by a discrepancy in their data. According to the standard model of the time, galaxies were supposed to be moving away from us uniformly, carried apart by the expansion of the universe. It was supposed to be a tidy, predictable recession. But the data was messy. Our entire neighborhood was streaming in one direction, like a fleet of ships caught in an invisible current. In the 1980s, a group of 7 astronomers, who called themselves the 7 Samurai, set out to find the source of this current. They were looking for the Great Attractor, a gravitational leviathan massive enough to organize the motion of thousands of galaxies across hundreds of millions of light years. But they hit a wall, or rather, they hit a curtain. The source of our motion sits almost directly behind the plane of the Milky Way. Because we live inside a flat disk of stars, gas, and dust, our own home galaxy blocks our view of the very thing that is pulling us. This region of blindness is known as the zone of avoidance. Imagine you are driving a car at 630 kilometers per second, but someone has taped a thick, black strip across the center of your windshield. You can see the cars to your left and right veering toward a single point, but you cannot see the point itself. You are flying blind toward a gravitational drain that your own home is actively hiding from you. It took the development of X-ray and radio astronomy to finally see through this curtain. X-rays can penetrate the dust of the Milky Way in a way that visible light cannot. When we finally looked through the zone of avoidance, we didn't find a single object. We found a cosmic watershed. To visualize this, think of a topographical map of a mountain range. On a mountain, every drop of rain that falls eventually finds a path. Some drops flow into small streams which join larger rivers, which eventually all drain into the same massive basin. The universe is organized into these drainage basins. In 2014, a team of researchers led by Brent Tully mapped these flows and discovered our home, Laniakea. Laniakea is a Hawaiian word meaning immeasurable heaven. It is a supercluster, a cluster of clusters, containing approximately 100,000 galaxies and spanning 520 million light-years. 520 million light-years. If a beam of light, the fastest thing in existence, tried to cross Laniakea, the journey would take longer than the entire history of complex life on Earth. When that light started its journey, the first multicellular organisms were just beginning to appear in the oceans. By the time it reached the other side, humans would have evolved, built empires, and discovered the telescope. Within this immeasurable heaven, the Milky Way is not a central player. We are located in the suburbs, a tiny tributary on the outskirts of a flow that is drawing us toward a gravitational center known as the Norma cluster. Norma is the drain of our local watershed. It is a dense, heavy concentration of galaxies and dark matter that sits at the bottom of our gravitational basin. Every galaxy in Laniakea, including ours, is currently sliding down the slopes of space-time toward this point. This 630 km per second flow is nearly double the speed of our previous layer of motion. It is the largest coherent gravitational flow that human science has ever successfully mapped. But there is a deeper complication, a second drain that makes our journey even more frantic. In 2017, data suggested that we aren't just being pulled toward the Great Attractor, we are also being pushed. Directly opposite the Great Attractor, there is an enormous cosmic void, a region of space where matter is significantly less concentrated than average. This is the dipole repeller. Voids do not attract, they are underdense, and in the geometry of gravity, an underdense region acts like a push. Matter flows away from empty spaces and toward dense ones. We are currently caught in a cosmic push-pull system, positioned between a void that is shoving us away and a drain that is sucking us in. The result is that your chair is moving through the universe at over 2 million kilometers per hour, and yet the coffee in your cup does not even ripple. The stillness of your room is now a mathematical miracle of the highest order. You are participating in a 630 km per second plunge toward a hidden destination, held in place by the same gravity that is dragging you toward your eventual merger with the rest of Laniakea. This is the largest motion we can measure using the landmarks of galaxies and clusters. It is the limit of kinetic motion, the movement of things through space. But we are about to hit a boundary where the very definition of moving begins to dissolve. Because while we are falling toward the Great Attractor, the space we are falling through is itself in motion. We are about to encounter the expansion of the universe, a layer of motion so strange it breaks the speed limit of light itself. The investigation is about to leave the drain of Laniakea and enter the cosmic microwave background, the absolute speedometer of the universe. We have spent this investigation stacking layers of motion like weights on a scale. We have discussed the 1,670 km per hour rotation of the Earth beneath your feet, the 30 km per second bullet plunge of our orbit around the Sun, the 230 km per second race around the galactic center, and the 630 km per second slide down the gravitational drain of Laniakea. By now, you may feel a sense of kinetic vertigo. You might be asking the one question that every physicist and every curious mind eventually lands on: is there a total sum? If everything is moving relative to something else, is there a way to calculate our real speed? Is there a final, absolute speedometer for the universe? Until the mid-20th century, the answer was no. Physics, particularly Einstein's relativity, tells us that there is no universal floor or a fixed point at the center of the void where we can set up a permanent radar gun. However, the universe has provided us with a quiet, ancient alternative. To find it, You do not look at stars, you do not look at planets, and you do not look at the galaxies we have been tracking. You look at the oldest light in existence. This is the cosmic microwave background, or the CMB. It is a radiation that fills every cubic centimeter of the observable universe, arriving from every direction in space simultaneously. It has been traveling for approximately 13.8 billion years. This is confirmed science, measured by multiple independent space missions. To understand why this light is our absolute speedometer, we have to look at the world it left behind. Approximately 380,000 years after the Big Bang, the universe was a screaming, opaque fog of hot plasma. It was so dense that light could not travel. Photons were trapped, bouncing around like pinballs in a crowded machine. Then, the universe cooled just enough for electrons and protons to combine into neutral hydrogen. The fog cleared. The light was released all at once, streaming outward in every direction. For nearly 14 billion years, that light has been traveling through the expanding dark, cooling from a white-hot 3000 Kelvin down to a freezing 2.725 Kelvin. It is the afterglow of creation, and because it fills the entire universe so uniformly, it acts as the closest thing we have to a metaphysical anchor. When you map this light across the entire sky with extreme precision, as the Planck Space Telescope did between 2009 and 2013, something startling emerges. Initially, the light seems perfectly even. No matter where you point your telescope, the temperature is 2.725 Kelvin. This uniformity is almost suspicious, a result of a period called cosmic inflation that stretched the early universe into a smooth, consistent sheet. But look closer. When you strip away the interference of our own galaxy and the dust of the solar system, a very specific, large-scale pattern appears. One half of the sky is very slightly warmer than the other. The difference is tiny, approximately 3.36 millikelvin, or about 0.003 of a degree. To a human, this is a non-event, but to a physicist, this is the final piece of the kinetic puzzle. This temperature shift is not a feature of the early universe, it is a feature of you. It is the Doppler effect, the same physical law that causes a siren to sound higher in pitch as an ambulance rushes toward you. Because you are moving through the universe, you are compressing the ancient photons in front of you, which makes them appear slightly warmer. At the same time, you are stretching the photons behind you as you leave them in your wake, making them appear slightly cooler. By measuring this dipole, at this temperature bridge across the sky, we can finally calculate the total cumulative speed of our entire journey. The number is 369.82 kilometers per second, 369.82 kilometers per second. In the time it took you to simply hear that number, you and the chair you are sitting in have traveled nearly 400 kilometers through the cosmos. By the time you finish this chapter, you will have moved further than the distance across the entire Atlantic Ocean. This is the net direction of your travel, the sum of every rotation, orbit, and galactic slide we have discussed so far. We are heading toward the constellation Leo. This is as close as we get to absolute rest. By using the CMB as our reference, we are effectively using the floor of the universe itself. It is a measurement of how fast you are moving relative to the very first light that ever escaped the darkness. Think about the coffee cup on your table. It appears still. You can trust it to stay there. But relative to the oldest thing in existence, that cup is a supersonic projectile screaming toward the constellation Leo at 1.3 million kilometers per hour. This is the partial resolution of our mystery. For decades, this number was the gold standard. It gave us an address. It gave us a velocity. It told us that our motion was not just a collection of random drifts, but a coherent vector through the architecture of space. We had found the absolute speedometer, and the data from the CMB was so precise that it seemed the investigation was nearly over. But as we have learned, every time we think we have reached the bottom of the universe, a new crack appears in the model. If the cosmic microwave background says we are moving at 369 kilometers per second, why do the most distant radio galaxies in the universe suggest we are moving twice as fast? This is not speculation. This is a 5 sigma discrepancy sitting in the peer-reviewed literature right now, a fundamental conflict that suggests our absolute speedometer might be lying to us. The investigation into your true speed is about to encounter its most terrifying complication yet: the radio dipole anomaly. We have arrived at the most uncomfortable point in our investigation. Until this moment, we have been building a hierarchy of speed that felt organized. We used the cosmic microwave background, CMB, as our ultimate anchor, the floor of the universe itself. It gave us a clean, precise number, 369.82 kilometers per second toward the constellation Leo. For decades, this was the end of the conversation. It was the absolute speedometer that allowed every other layer of motion, your rotation, your orbit, your galactic drift, to finally make sense as a single, combined vector. But right now, as you sit in your chair, a deep and fundamental crack is spreading through this entire model. This is not speculation. This is not a theoretical what if, or a creative interpretation of the math. This is a 5 sigma discrepancy sitting in the peer-reviewed literature right now, a conflict so robust and so persistent that it suggests our absolute speedometer might be fundamentally lying to us about how fast we are actually moving. To understand why this crack is so terrifying, you have to understand the difference between feeling the temperature and counting the passengers. The CMB measurement we discussed in the last chapter is a temperature measurement. It relies on the Doppler effect, the way light waves are compressed in front of us and stretched behind us, creating a slight temperature difference across the sky. But in recent years, multiple independent teams of astronomers decided to verify this speed using a completely different method. Instead of looking at the heat of the oldest light, they decided to look at the distribution of the most distant objects we can see, radio galaxies. The logic is straightforward and relies on the same principle as your car windshield in a rainstorm. If you are moving through a universe that is roughly uniform, you should see more objects in the direction you are heading. You are collecting more of them in your forward field of view, while the objects behind you appear to thin out. Furthermore, the objects in front should appear slightly brighter because you are rushing toward their light. This is called the radio dipole. If our standard model of the universe is correct, the radio dipole and the CMB dipole should be identical twins. They should point in the same direction, and they should report the exact same speed. The data shows they do not. When astronomers counted the distant radio galaxies across the entire sky, the direction matched. We are indeed still heading toward Leo. But the speed was impossible. The radio dipole is approximately 2 to 4 times larger than what the CMB predicts. If the CMB tells us we are moving at 369 kilometers per second, the radio galaxies are screaming that we are moving at over 700 or perhaps even 1,400 kilometers per second. Let that number sit for a moment. 700 to 1,400 kilometers per second. In the time it takes you to simply adjust your posture in your chair, the radio galaxies suggest you have traveled over 1,000 kilometers through the void. This is not a minor rounding error. This is not a calibration hiccup or a slight variation in the data. This is a massive structural disagreement between the two most important measurements in cosmology. In physics, we use a measurement called sigma. to determine how likely a result is to be a fluke. A 3 sigma result is interesting. A 4 sigma result is a serious problem, but 5 sigma is the gold standard for a discovery. It means the probability that this discrepancy is just a random statistical accident is approximately 1 in 3.5 million. This discrepancy is a 5 sigma crack in our understanding of reality. To humanize this, imagine you are on a train. You look at the speedometer on the wall and it says you are going 100 kilometers per hour. You feel safe, you trust the instrument. But then you look out the window and count the telephone poles passing by, and according to your count, you are actually traveling at 400 kilometers per hour. Both things cannot be true. Either the speedometer is broken, or your understanding of how the telephone poles are spaced is fundamentally wrong. If the radio dipole is right, it implies one of 2 terrifying possibilities. The first possibility is that our standard model of the universe is incomplete. We have always assumed the universe is isotropic and homogeneous, meaning that on the largest scales it is the same in every direction, like a perfectly smooth sheet of glass. This Copernican principle is the foundation of almost everything we know about space. But if there are twice as many galaxies in one direction than the other, the glass is not smooth. It is warped. It means the universe has a preferred direction, a cosmic north and south that we were never supposed to find. The second possibility is even more unsettling. The CMB is not the absolute speedometer we thought it was. It suggests that our entire local region of space, everything we have mapped from the Earth to the Great Attractor, is being carried by a bulk flow that the CMB light simply doesn't capture. It suggests we are moving much, much faster than the floor of the universe says we should be. This is the law gap. Most documentaries will tell you that we move at 369 kilometers per second and leave it there, as if the mystery is solved. They will give you the partial resolution and let you sleep soundly. But the data sitting in our current journals tells a much more chaotic story. It tells us that while you sit in your quiet room, the very instruments we use to measure the universe are in a state of open conflict. The speedometer and the telephone poles are giving different answers, and the gap between them is wider than anything our current physics can bridge. Your coffee is still, your chair is still firm, but the mathematical reality of your motion has just doubled or quadrupled, and we don't know why. We are no longer just looking for a number, we are looking for the source of the disagreement. And that search is leading us away from the visible galaxies and toward a possibility that sounds like science fiction but is becoming a statistical necessity. If we are moving twice as fast as the expansion of space allows, then something must be pulling us. And if we cannot see that something anywhere in our observable maps, then it must be located beyond the horizon of the universe itself. The investigation is about to leave the measured universe and enter the realm of dark flow, the possibility of an 8th layer that we can feel but can never, ever see. We have reached the point where the ground of reality begins to feel significantly less solid. Until this moment, we have been building a hierarchy of speed that felt, if not comfortable, at least measurable. We tracked the rotation of your chair, the orbit of your planet, and the slide of your galaxy toward the Great Attractor. We even found what we thought was the absolute speedometer of the universe, the Cosmic Microwave Background, CMB, reporting a total velocity of 369.82 kilometers per second. But as we discussed in the last chapter, that speedometer is currently in a state of open conflict with the distant radio galaxies of the deep universe. This 5 sigma discrepancy tells us that we are moving much faster than our current models allow. And that realization forces us to face the most haunting possibility in modern cosmology. It is a phenomenon known as dark flow. To understand dark flow, we have to first understand the physical limits of our home. When we speak about the universe, we are usually referring to the observable universe, a sphere roughly 46 billion light-years in radius, with you at the very center. This is our bubble. It represents the total volume of space from which light has had enough time to reach us since the beginning of time. Everything we have mapped so far, every star, every galaxy, and the great attractor itself, is located inside this bubble. We have always assumed that our bubble is all there is, or at least that it is a fair and balanced sample of the rest of the cosmos. We assumed that if we were moving, the cause of that motion must be something we can see, or at least something located within our 46 billion light-year neighborhood. This is not speculation. In 2008, a team of researchers led by Alexander Kashlinsky at NASA's Goddard Space Flight Center published a discovery that fundamentally challenged that assumption. Using a highly specialized technique called the kinematic Sunyaev-Zeldovich effect, they measured the velocities of hundreds of distant galaxy clusters. They weren't looking for the local slide toward Laniakea. They were looking for a bulk flow, a coherent, large-scale streaming of everything in the observable universe. What they found was a current. The data shows that our entire 46 billion light-year sphere of existence appears to be sliding in a single, unified direction. It is not a random drift. It is a directed, organized motion of galaxy clusters that extends across distances far larger than any known structure in our observable maps can explain. The speed of this dark flow is estimated to be approximately 600 to 1,000 kilometers per second. 600 kilometers per second. In the time it takes you to simply blink your eyes, the entire observable universe, every galaxy, every black hole, every atom of gas, and the chair you are sitting in has been carried 600 kilometers through the dark. By the time you finish your next cup of coffee, you and everything you have ever known will have been swept 250,000 kilometers further along this cosmic current. This is the eighth layer of your motion. It is a motion so vast that it does not just involve you moving through the universe, it involves the entire universe moving with you. But the true terror of dark flow is not the speed, it is the destination. The source of this motion, the great attractor of this eighth layer, is not visible in our telescopes. It is not hidden behind the dust of the Milky Way. According to the research, the source is located beyond the cosmological horizon. We must be very precise about what this means. The cosmological horizon is the absolute limit of human knowledge. Because the universe is expanding and because the speed of light is finite, there is a distance beyond which no signal can ever reach us. There is an outside to our 46 billion light-year bubble. If dark flow is real, it means that our entire observable universe is being pulled by something so massive and so powerful that its gravitational influence is reaching across the horizon, grabbing our entire bubble of reality and dragging it toward a region of space we can never see, never reach, and never confirm. Imagine you are a passenger inside a windowless cabin on a ship. You have lived your entire life inside this cabin. You have mapped the furniture. You have measured the vibrations of the floor. You have even calculated your speed relative to the dust motes in the air. You feel safe because you understand the mechanics of your room. But then you notice a subtle, persistent tilt. You realize that your entire room, including the floor you trust and the walls you rely on for sanity, is being carried by a current in a vast, dark ocean outside. You can measure the drift, you can feel the turn, but you can never open a door to see the ocean. You can never look out a window to see the hand on the wheel that is steering your entire world toward a destination you will never know. This is our situation. We are in a vehicle with no windows, and the driver is in a region of space that the laws of physics have permanently sealed away from us. At this point, we must enter a state of honest uncertainty. In the years following Kashlinsky's announcement, the scientific community entered a period of intense, ongoing conflict. In 2013, the Planck Space Telescope, the most precise instrument ever built for mapping the ancient light of the universe, looked for the dark flow signal and did not find it at statistically significant levels. This has created a deep fracture in the peer-reviewed literature. One team sees the current, the other sees a calm, static sea. This is not a failure of science, it is science doing exactly what it is supposed to do. It is tracing the observable world to its absolute edge and being honest about the fact that our instruments are currently giving us two different answers. However, the crack we discussed in the last chapter, the radio dipole anomaly, remains. If we are indeed moving twice as fast as the expansion of space allows, then dark flow remains the only logical explanation currently sitting on the table. It suggests that the eighth layer is real, even if we cannot yet agree on its magnitude. Think about your room again. Think about the stillness of your coffee. We have stacked 7 layers of motion on top of you, each one confirmed and measured. But this 8th layer represents the ultimate humbling of the human species. It suggests that our entire history, from the first stone tools to the first moon landing, has taken place inside a tiny, localized bubble that is itself a passenger on a much larger, darker journey. We are not the masters of our trajectory. We are not steering the ship. We are microscopic specks of matter pinned to a spinning rock, falling around a star, drifting through a galaxy, and potentially being hauled across the cosmic web by a gravitational leviathan that exists outside of our universe. The stillness you feel is a biological mercy, a neurological edit designed to keep you from the existential paralysis of realizing you are part of a 600-kilometer-per-second plunge toward an unreachable horizon. This is the limit of the investigation. We have reached the edge of what can be measured, and we have found a question that may never have an answer. But before we end, we have one final task. We must return to the beginning. We must take every layer of motion we have discussed, every supersonic spin, every bullet-speed orbit, and every intergalactic current, and stack them all together for a final reckoning of what it actually means to sit still. The investigation is coming home.